Hey guys, welcome to my webinar from 50 Shades of APIs to the least shady. I hope most of you are fresh, and if you guys are already familiar, this is 7 a.m. in the morning in New Zealand, and um, some of you, if you know me already, I'm not a morning person, so if I'm not as eloquent as I could be, apologies for that, and I'll try my best to be on the top of my game. So today we're going to talk about various different shades of APIs which emerge in the RESTful world. And because this is a platform engineers community, we're going to take a specific angle from platform as well. There are different challenges which emerge over a long period of time, and we're going to cover how we can best address them with few little paradigm shifts. Without further ado, let's dive right in. A bit about myself. We'll start with my professional life. I have 1.5 decades of professional experience in software development and architecture. Started as a .NET developer, moved my way up to architecture, solution architecture. Now I am at the principal architect level in a bank in New Zealand. Most of you might not know about Kiwibank, but this is one of the banks in New Zealand, and we are going through a massive digital transformation program, and I'm responsible for the integration patterns and practice across the entire digital transformation program. This is quite an exciting journey, and there are a lot of experience and learning which I can share in this webinar and perhaps in the following few in the future, if you enjoy my webinar. So I worked in fintech, agri-tech, fit-tech, and now I'm working in core banking. I had full spectrum experience from startups, scale-ups, and large enterprise digital transformations. So I also practice digital domain-driven design, event-driven architectures. What other things which were really interesting? Microservices and architecture modernization for the last 10 years. A little bit about my personal life. We have a young family and we are a mixed couple. My wife is interestingly Dutch, and I do travel a lot to Europe. Not a lot, sorry, at least once a year. And I've been quite a lot to Berlin, Munich. I have quite a few friends there as well. So if some of you are from Amsterdam, Berlin, or Munich, feel free to connect with me. And when I'm next time in Europe, I would love to catch up. And can I ask a quick question? If any of you are joining from the Pacific region, Australia, New Zealand, Maria, any hands up?
Yay, Greg from New Zealand.
Oh, thanks, Greg. He's one of my past colleagues, and we're really good friends. I appreciate you, Greg, you joining this early in the morning. So, moving on to my passion. Some of the guys like Greg know me that I'm really passionate about digital transformation and architecture. I think almost all the large enterprises are going through a digital transformation program, considering the massive wave of technological disruption coming in various traditional industries in the last few years and in the coming decade as well. And the challenge for most large organizations is that the success rate of digital transformation is less than 1/3. 2/3 of the digital transformation programs are considered to fail to deliver the intended business value in the reasonable timeframes. And when we talk about digital transformation programs, they go about easily 5 to 7 years in a large enterprise. So my passion is to increase the success rate of digital transformation programs. And this is one of those thoughtcasts which I think could help in that process. Right. We'll move on to the actual talk agenda. So I've got 4 sections to cover off today. And the first one is three-dimensional scalability in sociotechnical systems. And I'm going to cover a little bit about what sociotechnical systems are and what do I mean by social scalability, three-dimensional scalability. And we'll cover comprehensively many different shades of APIs. Don't hold it against me if it doesn't count all the way to 50. And then we're going to talk about 2 different paradigm shifts, which can help us unlock three-dimensional scalability. And then a few do's and don'ts in digital transformation. Right. So one of the first question is, what is a socio-technical system? This is one of these buzzwords which have recently become really popular. If you go a few years back, we used to think about application architecture, solution architecture. We used to talk in enterprise architecture. And then came the terminology system thinking, when we started considering our entire technical capabilities as a single system to deliver the operating model of an enterprise. And then soon after, we started talking about socio-technical systems because people started talking about the interdependencies between the technical decisions and the team structures and vice versa. So if many of you are already familiar with Conway law, you will know that over time, your technical architecture will reflect your team structures. And if you actually make if you do it the other way around, your technical decisions have also impact on your social dynamics of your teams as well. So, well, I perhaps should have pressed this button earlier. Right. So what is scalability? Interestingly, if some of you followed some heated debate towards mid of last year, Amazon released an article about their Amazon Prime microservices being refactored, and that's steered up a debate between microservices versus modular monolith. And people took that article quite literally in terms of jargons used in the article, and they started bashing about microservices, and they're like, hey, modular monolith can be equally scalable. And then the other school of thought was arguing that microservices are a lot more scalable than modular monolith. And people were not coming to an agreement. In my view, both schools of thoughts are correct. The problem is they have 2 different interpretation of word scalability. They're focusing on 2 different dimensions of scalability when they are talking about modular monolith and microservices. I think this comes down to the basic fundamental definition of scalability, not per se how we use it day to day in our language in technology. Scalability simply is, when we are growing something while reducing the per unit cost of that thing which we are growing. So let's look at example of businesses, right? If you talk to any capital investor, they will see sometimes businesses which are very profitable, and any business you can grow if you pour the right amount of money into it, and any business can grow if you keep replacing or replicating your business operations. However, a lot of the times investors are considering the scalable nature, which means how fast I can reduce the cost per unit of growth. So not every business can be highly scalable, and this is a very fundamental difference between growth and scalability. And interestingly, when software or infrastructure or technical people often talk about scalability, they're quite often focused on a specific dimension of scalability, which is infrastructure scalability. We're talking about, hey, when our system grows in the number of user base, when our system grows in the user base over a period of time, how cost effectively we can handle the infrastructure to manage the workload and demand from this growing user base. Ironically, infrastructure isn't the only thing which grows along with your business and your technology. The other two dimensions are functionality and teams. They both grow or shrink over the period of time as well. So as you keep growing as your business grows, your consumer base grows, you keep adding new functionality in your system, and it keep growing like a metropolitan city. So without some very good urban planning, your city can turn into chaos. And same applies to your system architecture as well. Second thing, teams. Team scalability is also very vital because as you're growing your teams, if anyone familiar with Mythical Man Month, you can't keep growing your teams and your number of engineers and expect that the same throughput if you're not being very careful how these teams are going to interact, how you're going to maintain their autonomy, and how the work will flow into those teams as well. So we have to focus on three different dimensions of scalability when we are talking about our system. And ironically, when people debate about microservices versus modular monolith is equally scalable when it comes to infrastructure scalability. So when people are saying modular monolith and microservices are equally scalable, they are actually talking about infrastructure scalability. But when it comes to team autonomy, team independence, and flow engineering, that's where we talk about team scalability. And that's where I think microservices are a lot more scalable in team autonomy, team scalability compared to modular monoliths. And again, don't hold it against me, because I'm sure, like any concept, there can be different views in the industry. And if you hold a different view, I'll be very interested to learn about it. But I think I'm not trying to, say that this is the only way to look at your system. Right. Let's dive into 50 shades of APIs that emerge in the RESTful API thinking. And of course, we're talking about platform engineering, where we try to reduce the cognitive load of the stream-aligned teams. And in order to do that, often we choose microservices and, containers orchestration and all that stuff. So microservices play a vital role in, large scale platforms. Right. I think I jumped a little bit in this slide. So one of the key paradigm shifts I want to bring into discussion today is GraphQL federation, not just GraphQL federation. And I'm going to show you how when people are trying to bring this modern architecture pattern into discussion in their teams and in the company, some of the arguments or misconceptions they commonly hear are that REST is good enough, GraphQL is only for user experience, and GraphQL is only good for querying. These are common misconceptions, which I think we can address thoroughly later. Right. Let's dive into enterprise API landscape as it emerges with RESTful APIs. So of course, when we're building a microservices, what we are saying is that we are encapsulating the business logic and the database within a boundary, and there's going to be a very well-defined interface to interact with that microservice, and nobody can just talk to the business logic and database directly. So quite often, one of the common ways to draw up that contract is API for microservices to talk to each other. So let's say we are building homegrown microservices for the distinguishing business capabilities in the business. And at the same time, we don't want in a large enterprise to build everything ourselves, because not every business capability and business function is a distinguishing factor for the business. So if you're doing stuff which does not add competitive edge to your business, you're better off taking SaaS solutions or commercial off-the-shelf solutions and just reusing them and maybe customizing them to your business needs. And when we are doing that, one of the things we want to avoid, of course, is when you're building your homegrown microservices, you don't want them to directly talk to off-the-shelf commercial off-the-shelf solutions, which belong to a completely different business capability. So if you do that, we are causing what I call procurement coupling. If let's say you took inventory management solution in an e-commerce solution, e-commerce business, you took a inventory management solution and you let your sales modules and your sales microservices and shipping microservices to talk directly to that specific commercial off-the-shelf solution. You have this procurement coupling in your system because every time in the future you have to remove this commercial off-the-shelf solution, you eventually have to go and make that change in many other places. So there's a cascaded effect on other areas of the business, which often slows down the business, digital transformation. And interestingly, a lot of the times when we are taking these off-the-shelf solutions, we can easily assume that they're going to last for a very long period of time. In my experience, I've seen quite a few times in my career that we take an off-the-shelf solution from the market, and a few years later, that company gets bought out by another big company, and there's a massive shift in the business strategy or their terms and conditions or their contracts. And at some point, business is thinking this is not very viable solution for us, and we want to move away from it. And I've seen it happening quite a few times in my career. So what we need to do is actually wrap our commercial solution into a shell microservice as well. Of course, a commercial off-the-shelf solution can be beyond a single business capability. Quite often, one commercial SaaS solution, commercial COT solution, give us multiple business capabilities. But we shouldn't try to wrap it all in one microservice. We should create our microservices around business capabilities or bounded contexts. So of course, this is a very simplified view where I just created one box around the commercial off-the-shelf solution. And then ideally, we need to define our API contract or whatever contract that microservice has as per our business domain. So that creates an anti-corruption layer in the domain-driven design language. We create an anti-corruption layer so our other microservices do not get affected when we replace our commercial off-the-shelf solution in the future. So that's like future-proofing our investment. And what we do here is that we increase replaceability of our SaaS vendors in the future. Right. Let's say we keep building our microservices for different business capabilities. Some of them are homegrown, some of them are just shell around SaaS solutions. And of course, we know that this is not how they don't exist in isolation, and they don't only talk to your front-end applications or channels. They also need to talk to each other for business processes which span across multiple business capabilities. And in order to do that, we often end up, if this is the only contract we got with our microservices RESTful APIs, then we end up with point-to-point coupling between our APIs. And when one microservice finishes its task, business task, and when I say business task, I am using business BPMN notation, business process modeling notation. So a business task is a small task which fulfill a business value. So when the microservice one finishes the business task, it needs to trigger next task in the business process. So it will call the other API of the other microservice. And that's point-to-point API calling between microservices. And that's what I call messaging coupling. Because our microservices are coupling with each other or messaging each other, what happens over time is that these business processes do not stay consistent or constant. Business might want to trigger another business task when microservice 2 has finished its task, they might want to say that there's another microservice X which needs to be triggered. So in order for us to do that, we don't only have to implement microservice X, we have to go back to microservice 2, and so that microservice 2 can actually trigger microservice X. And that's the classic example of messaging coupling. This is a very simplified example, by the way. There are much more I can deep dive into if I talk about individual coupling patterns, but this is a simplified explanation. Right. So this was a class example, but I'll just skim through that. So another option to reduce that point-to-point coupling between messaging coupling between your microservices is to introduce another abstraction on top of microservices, which is very popularly known as process APIs or process services. So your microservices deliver individual business capabilities, and your inter-service processes are encapsulated in separate services in a layer above. So what happens is that you can call this lower layer system APIs, and you can call the upper layer process APIs. And what happens is that for each process to fulfill its implementation, it might be talking to multiple microservices underneath. But if you look at it, this is still messaging coupling, just abstracted away from your business capability layer. Because every time you introduce a new microservice X, which needs to be triggered after microservice 2, you don't have to go and make the change in microservice 2. However, you might have to go and actually make the change in the process layer above. So this is where a classic example of orchestration actually introduces this messaging coupling. I'm not fully against orchestration versus choreography, and actually I have a few very good use cases, which are not the topic for today's conversation. There are a few very good use cases for orchestration. However, between microservices, when they want to do inter-service communication, I think orchestration and process APIs do introduce this messaging coupling. Right. I'll keep building a big picture, and eventually we're going to see some high-level problems with that. Presentation apps and layers. This is where we have all the different apps, mobile apps, your front end, web apps. If you are building, public APIs, you might have third-party apps talking to those APIs as well. So interestingly, your landscape can be very broad and can grow very quickly in the coming decade, because there might be new types of IoT devices or new types of metaverse devices or ChatGPT driven AI devices, which will also need to interact with your system in the coming future. So your channels or presentation layer can be very broad in the coming decade. And of course, these apps span across multiple processes. They give capability of handling different functionalities in your system. So they are also talking to multiple processes. And this is the classic example of navigation coupling, because your apps actually having to navigate individual processes, APIs themselves. So every time you would like to refactor your process boundaries or APIs underneath that, you will have to go and make the changes in the dependent apps as well. And that makes it really hard and slow to introduce the change across your system, because you have a lot of dependencies and coupling, which slow you down to release your change. You often end up creating a lot of new versions of REST APIs, and eventually you have to manage all those API versions unless and until all the apps have actually moved on to your new latest version.
Hey, Arsalan, quick thing. And for me as well, I see some attendees are saying that slides come out as a bit blurry, especially this like
Strange.
big thingy.
I can switch to the different view.
Yeah, let's try.
Yeah, thanks. Oh, it's blurry. Sorry. Now let me just quickly. How about this one? Perfect. Is it better?
Still blurry on my side. I don't know, guys. What do you see?
Oh. Is it blurry, guys?
Yes, still blurry.
Okay, let me see if I can just directly share the slides. And I'll keep this on this, and I'll move to the Zoom and share my slides. That will be good. Let's hope that PowerPoint. Okay, let's see. Is my PowerPoint? Yes. Oh gosh. Let me. Yes, this should work. Sorry, guys, for the inconvenience.
No worries.
Not expected. Oh, it wants me to quit and reopen Zoom.
Okay.
Oh, can I do that if you don't
Yeah,
mind?
yeah, no worries.
Nice. Let's see if I can share my. Can you guys see it better?
Yeah, now it's much better.
Awesome. Yeah, it was an experimentation with OBS. Perhaps I need to figure out how that works better. Anyway, I'll get back to this, right? So I'll try to, sorry, I'm going to go back. Yes, right. So basically, when you don't want your apps to be directly talking to individual APIs underneath, process APIs or individual APIs underneath, you often end up introducing experience APIs. A simplest way to develop an experience API is, of course, building a single facade on top of your all the process APIs or microservices, and that single facade becomes accessible for all the apps. Now, the challenge there, of course, is that REST APIs, of course, have a very, very fixed response. Sorry. It has a very fixed response for each endpoint API calls. And what happens is apps end up doing underfetching and overfetching. And one of the solutions to that underfetching and overfetching problem with your facade API, which is classic gateway pattern, is that building individual BFFs, backend for frontend. And this is what I'm showing in this diagram. So I skipped the single facade option. I just quickly jumped to BFF example. So when you're building single BFF for each different types of apps, you actually abstract away and reduce that navigation coupling, because your apps do not need to talk to individual processes underneath. They just talk to a single consistent interface which serve their needs, and they don't have to know the details of the underlying system structure at the back end. So if we continue further, interestingly, experience APIs have further different shades as well. If you are in a, if you're part of an enterprise which has only one business, you will often have just BFFs for different apps for different kind of devices. Now, in a large enterprise, we often have multiple businesses under the umbrella because enterprise is just a legal structure and they might be running multiple businesses. And quite often, what they want to do is they want to deliver omni-channel experience or landing pages across different business systems. So you often these systems are autonomous and separate as well, because not every business model is homegrown. Sometimes large enterprises acquire other businesses as well, and it takes a long time to completely bring them into one system. And it's also debatable whether it's worth bringing multiple businesses as a single system. However, if you want to build omni-channel experience on top of your multiple businesses, so you can combine their offers together, or single API interface for doing multiple things in different businesses. Now, what happens is you end up building enterprise APIs on top of your BFFs, which belong to your single business. And then if you're building public APIs, that's another layer of complexity when you want to deliver change, because in each outer hemisphere, you're losing control whenever there's a change coming from business capability. Quite often a business stakeholder brings a change. This is the reason, this is the necessity. We want to make a change in a single microservice or whatever. And then that change needs to cascade to the channels and the presentation layers. And ironically, a small team has very little influence over all the other teams and their dependencies and their priorities. So you have to go into outer hemisphere of your APIs to deliver that change, and that makes it really slow and hard to deliver the change for the business, and it affects business agility. Right. So this diagram still stays simplified. I'm not going to put all the other hemispheres of experience APIs. But this is a classic API-led connectivity pattern, which is very popular on the internet, apparently. And some people really buy into it, and perhaps it works for some people. However, in my experience, this really goes against the narrative of digital transformation in the large enterprises. Companies are pouring tens, if not hundreds of millions of dollars to introduce business agility and competitive edge for the coming decade. So they're building digital transformation programs which are going to deliver value in 5 to 7 years, and they're trying to prepare themselves for the next 10 to 15 years. And in order to do that, you got to pick patterns which are going to be introducing business agility and competitive edge in the future. And in my view, the problem with this pattern is that I call this API-led coupling pattern, because you're introducing these many layers of APIs, this layers of abstractions. And whenever we'll see an example, a small change, how difficult it is to cascade that change through the different layers, right? So what I like to say in a situation like this, if only tool you have is a hammer, everything looks like a nail. And this quite often applies to technology as well. This is one reason we try to encourage our engineers and architects to keep learning, keep their growth mindset, because the more tools, the more technologies, the more patterns we'll learn and experience, the broader our tool set will be when it comes to addressing a problem. And we will not see everything like a nail when we only know about hammer, right? So what happens here is that, let's take an example of a simple change request, as simple as exposing a single field in a single microservice, right? And there can be many use cases, many examples. I'm just going to keep it very simple. If you want to expose a single field, new field in an existing microservice in API-led connectivity pattern, let's look at how it goes. Let's say microservice 2 needs to introduce a new field that needs to be used across the processes and apps which are going to be using the capability which is in microservice 2. Now, in simplest example, if you had only 3 processes which rely on microservice 2, and then only 3 apps with the 3 BFFs enabling that app's integration, then you end up having to deploy your change in 7 different independent services. So you have to deliver the change in microservice 2, and you're going to have to work through your layers of your API-led connectivity pattern to deliver your change. And interestingly, this was a very simple change when you're introducing a new field. If there was a scenario that you have to rename or break the introduce a breaking change in an API contract, the problem is that you have to work out the dependency, and you have to often release API versions, new version, and then when dependents have moved to the new version, then you deprecate the old version. So imagine introducing multiple versions across this API layers for a single change, like changing the name of a microservice field. So this is, in one way to put it, API-led connectivity is a deterministic coupling that shackles a team's productivity and business agility. And this is from me. Right. The next chapter is the 2 keys to unlock 3-dimensional scalability. Of course, as you were anticipating, I would have brought up GraphQL Federation, and I had already given the hint about choreography. So these are the 2 things which actually enables the real business agility and team productivity. Let's look at it a little bit more deeply. Right. So let's say we took out the process APIs because orchestration versus choreography. And instead of our orchestration, we introduce a choreography layer, and we are saying that all the microservices will be firing domain events, which are domain contract, just like APIs. And they fire their events whenever something happens within the microservice. And how the business processes work is that any other microservice which needs to trigger any reactive business task, they can simply subscribe to that event or topic, and whenever that topic gets an event, they get notified and they can react to that event and continue the business process. This is the classic choreography pattern. And of course, we're going to take out the experience APIs, RESTful experience APIs, and we introduce the concept of GraphQL Federation here. So the example, if you notice from the previous one in here, we not only remove the experience APIs, but we also introduced GraphQL at the microservice layer. A lot of the times I've seen that people are getting the Apollo Federation license from Apollo GraphQL, and they are keeping their GraphQL thinking above microservices. It can be because of your team structures, how your channels or apps teams or front-end teams are disconnected with your microservice or back-end teams. You got to make sure that you have cross-functional teams, and of course, you got to take your GraphQL thinking all the way down to your microservices. So what happens here is that your each microservice does not have a RESTful API; it has a subgraph. And because of GraphQL Federation pattern, if you introduce a change in this microservice subgraph, it automatically cascades above to the supergraph. You don't have to introduce that change explicitly. You don't have to deploy your change explicitly to your experience layer or GraphQL Federation. It self-composes its supergraph schema whenever the subgraphs introduce any new change. I'm not going to go into too much technical details, of course, because I'm an architect and I try to work with boxes and arrows. Right. So let's look at the last request, and I'll try to wrap up quickly. Let's look at that previous example again of introducing a new field. What happens here is that when you have that change, instead of deploying your change and testing it at 7 different CI/CD pipelines, you only have to focus on one, which is your microservice. And you deploy your change to your microservice, and you expose your field into the subgraph. Your supergraph self-composes itself, and that makes it available to the apps to consume it. And I'm sure you might have a lot of questions around how the eventing would work and how the breaking change, for example, changing the name of a field will work. And I can happily answer those questions in the Q&A, but I'll try to keep going forward to wrap up fast. So what's the takeaway? Let's say you guys are part of any digital transformation program. Sorry, there can be three different cases. If you are in a traditional enterprise, if you're in a tech industry, you might not have a digital transformation program because apparently you should be transforming all the time and modernizing your product. So if your company doesn't have a digital transformation appetite, of course, you can still remove navigational coupling by building GraphQL wrappers on top of your microservices, which are already built on REST. So you can introduce your GraphQL federation on top of your RESTful microservices with very little effort. Second case is that your digital transformation, your organization is in the middle of a digital transformation, and already they have built a lot of microservices in the target state architecture with RESTful APIs. What do we do now? Well, the takeaway is that you don't really have to go and apply GraphQL federation thinking retrospectively. You can build one big monolithic subgraph to wrap your existing RESTful microservices, and you can build your future microservices with your subgraphs. And in the future, you can introduce and refactor your existing microservices only where you notice that business has frequent changes to your microservices. And third case is that your organization could be starting a digital transformation program, and they're trying to decide their target state architecture. And this is where I think an organization have the best opportunity to capitalize the maximum potential of GraphQL federation and choreography. And the takeaway for these kind of organizations, which are at the start of their digital transformation program, is REST will keep you restless. Let it rest in peace. And last section, wrapping up, do's and don'ts of digital transformation. This is a really broad topic, and I'm only leaving a cliffhanger here for the next sequel. I have quite a few original and innovative improvisations on my learnings over the years, and I've come up with few original ideas, which I'll be talking about in the recent future as well. I have cataloged 11 sociotechnical impairments, aka coupling patterns, and every letter in the word impairment represent a unique type of coupling. And I've also discovered a very efficient way of digital modernization, or architecture modernization, as some people like to say. So, which is what I call intergenerational integration. When you're trying to apply strangler pattern on your legacy system and you're trying to build your target state architecture, you gotta handle 2 generations of your system at the same time. This is where intergenerational integration will be very, very useful. The last one is D5 model for accelerating your transformation roadmap. So a lot of people are already familiar with C4 model, and D5 model is just my improvisation on C4 model with domain-driven design thinking and my opinionated view of how things work in the large enterprise transformations. So that really can be really helpful for the large digital enterprise transformations. This is it. I'm going to open the floor for, last 10 minutes for questions. And if you guys really enjoyed the talk, please feel free to follow me on LinkedIn, and I'll be posting there about my future talks. I'm also invited to a conference in Singapore in April. So hopefully some of you might be interested. So please feel free to follow me. I'm going to take the questions now.
Can you go on
Yeah.
camera? Because I think you have your camera off.
Sorry, did you say I can turn my camera off? Okay.
Turn it back on because you're.
Oh, yeah. Sorry. Thank you.
No, still off.
Yes. There we go.
No.
You can't see me? Oh, yes. I know what. Apologies. I mean, you can bring the question already, of course.
Yeah. So the first question is, what's your favorite tool chain for the choreography layer?
Ooh, I have practiced a lot with Confluent Kafka. However, I really enjoy some unique features from Solace. I haven't had the chance to practice it in the enterprise environment yet because the transformation programs I've been part of, they already had made decisions on the tooling. So Solace is something which looks very futuristic in some of the features. However, Confluent Kafka is our go-to in terms of maturity and reliability.
Nice. Could you share something about D5?
Right. So D5 model is well, one additional layer, of course, and the top. So there's a opinionated view I have on how we should go about categorizing domains, subdomains, and bounded contexts. And a lot of the times, many different architects view it a little bit differently. I try to define the domain at the level of business model and apply the system thinking to an entire business model. And then below that, every business has business functions or need business functions. So I try to apply subdomains at that level. And then the bounded context is within a business function, you got different business capabilities. For example, your accounting might have account receivables. It might have account payables, invoicing. So these are different business capabilities, which are bounded context. And then in a large enterprise, ironically, this is not only one business, right? In large business companies, they have multiple businesses. So you got to decompose and distill them as well at the large enterprise level. And that's the D1 level, where you're talking about domain landscape or business model landscape. So far, business model thinking is quite popular in startups. I'm actually writing an article, which I hope to publish for Harvard Business Review. I'm not sure if it's going to get accepted, but the idea is that I'm taking the business model thinking and applying it at the large enterprises, because in the next decade, large enterprises need business agility and ability to divest away from their one of the businesses very quickly, or be able to keep scaling these businesses separately and autonomously. The problem is that a lot of the enterprises are not thinking about their individual businesses as autonomous, and they end up being coupled in the same business capabilities. And eventually, when you want to make a change or scale one business, or you want to divest away, sell one business, you have to go through a large, decoupling process when you're trying to sell your one of the businesses. So I have introduced the concept of business model disentanglement or decoupling at the D1 level, and then the D2 to D5 level are like C4 model. However, they have a little bit of opinion from me how it's most effective to draw out the diagrams to make it more effective and useful. Sorry, a little bit of scenic tour.
No worries. Very cool. Well, while guys, you are typing your next questions, in case you're going to KubeCon, also wanted to share that we'll be hosting this cool party for platform engineers, DevOps, everyone who is in our platform engineering community. So if you will be there, welcome. See you in Paris. And well, we'll have lots of fun, I hope. And see some questions. Are you going to KubeCon or no? You told me that, yes.
Well, I have submitted my proposal. I haven't heard back yet. So it's not a denied yet. So if it gets accepted, hopefully I'll see you there.
Okay, yeah, perfect. See, there is some questions on YouTube. So how does this support not making a request succeeded unless multiple data domains reply success? Choreography requires replying success a little bit earlier, no?
Sorry, could you please repeat the question again?
Yeah. How does this support not making a request succeeded unless multiple data domains reply success? Choreography requires replying success much earlier.
Right. I think apologies if I misunderstood that. I think there are two distinct patterns when it comes to choreography or inter-service, transactions, distributed transactions. One is two-phase commit, and this is where every microservice has to confirm that they can commit to this change, and then you actually commit your distributed transaction. That's two-phase commit. The second pattern, which is very popular, is saga pattern, in which you're not really trying to do two-phase commits. One microservice does its thing, it changes its state, the second one changes its state. If the third one fails for some reason, then you have the compensating events or compensating transaction to revert the change where need be. Interestingly, I forgot to put that in my on my upcoming talk slide, that I have come up with a very effective pattern to reduce the complexity of saga pattern. I like to call it karaoke pattern. So it's just a third alternative to orchestration and choreography, and I call it karaoke pattern. So I actually have proposal for that talk in few conferences. Hopefully one of them get accepted, or I will be more than happy to deliver a webinar through this channel if there was enough interest. So if you guys, sorry, I forgot to mention that we're going to be sharing a short survey. I put a lot of effort and energy to prepare this webinar. I'll really request you guys to take that short survey and give us some feedback. And one of those questions I will be asking that, which of these topics you guys are interested in, so I can actually put my energy into the topic which is the most interesting to the audience. So yeah, I think I can cover that topic in one of the talks.
That would be great. Very, very looking forward to it. And there is one more question from Greg. What challenges have you seen teams run into when building towards this GQL and choreography target architecture?
Oh, that's a whole new Pandora box. I think the biggest thing about digital transformation is it has very little about technology. Well, of course, technology plays a very vital role. You're right, decisions are important. I think a major chunk of your digital transformation challenges are people challenges. Your organizational inertia and converging different people onto a single direction, leading, inspiring and thought leadership across your teams. And I think adoption is a journey for teams. I've talked to many people. Actually, I was at GraphQL Summit and I delivered a talk there last year as well. And in what I noticed as a theme at the large organizations in America, everybody talks about you got to start and let teams play with one maybe subgraph or something. So I have a strategy around how you can go about adopting new technology with minimum, disruption as well as minimum, what we call it, poor architecture, poor implementation. That's the challenge because teams are learning. You got to give them a safe environment to start. And in my shortest answer is that you got to start with one small team as starting point, and they deliver and learn and develop their skills. And you take these engineers and spread them across other teams as champions so they can be part of other teams and they help adopt the same technology across the enterprise. And of course, platform engineering serves a role for stewardship as well. So that's where platform engineering can reduce the cognitive load for the teams. It can be a very long answer, but sorry, I can go on and on about this topic.
Maybe that's another topic for the webinar. But with that, I guess we are on time. So thank you so much to everyone who joined us today, this evening, or this morning. I saw some people were joining from Australia at 5 a.m. So it's really good to see an international audience. And thank you, Arsalan. I know that you spent almost sleepless night today. So hope you get some rest, and hope everyone has an amazing and safe, most importantly, rest of the day or the evening. Also wanted to remind you that we host these webinars every week, so you can just go to platformengineering.org and check out our next sessions. I think the next one will be on Thursday. And yeah, join Platform Engineering Slack. If you have any follow-up questions, please hit us up on the community. And also Arsalan mentioned about very important survey that he would like you to take. So I'm going to share the link with the follow-up email with the slides and the replay tomorrow. And
it will be a short one.
Yeah, very short. Anything else from you, Arsalan, just like to finish up this presentation?
Thank you so much for joining. Really appreciate that. And one of the things about the survey is that I'll learn what worked well, what you guys enjoyed, and where I can improve that as well. Thank you so much.
Thank you.